right now I'm going to teach you at least some of the basics as to how to identify minerals. If you like, I'm gonna let me just focus this. So much nicer than it was. So much nicer. Better. All right, that's better. No noise. I need all the noise. All right. Oh my goodness, this is making me very happy. This is making me very happy. All right. So I love it now. You can actually see the colors so much better. It's a bit dark still. There's one thing I can actually change for that. Maybe the lighting is a bit different in here than it was yesterday. I don't think it is. That is dioptase, by the way, the green one in the middle. All of the whitish looking minerals, I'm actually going to not tell you what they are, and I'm going to show you how to identify them. And I've got a bunch more in a mineral kit that I'm going to pull out as well. Things that look similar. I'm gonna have you guys identify them with me, and it's gonna be good. You recognize most of them? Well, some of you already might know. It is very pretty. All right. I hope this isn't too bright. Right, it's not too bright. So I'm gonna put some garnet in the frame. This is some androtite garnet. I just want to show off some of the minerals in this light. So there are multiple forms of garnet. This is only one, but I just wanted to show you just how much better the lighting is. Everything's clear. There aren't just big circles of light on the desk anymore. There are multiple points of light allow you to see various surfaces on the minerals, which is really, really excellent. Garnet is one of my favorite minerals. I love it. I really, really love it. Some of it is chipped away, which makes me sad. It's a very brittle mineral, and oftentimes used as an abrasive. But you can see in the box, there's a couple little pieces that chipped off right there, and it makes me very sad. Makes me very sad. Yeah, my hand actually looks like my hand. So this is dioptase. This has actually become one of my recent favorite minerals. It's a silicate. I think it's brittle, but these the little tiny crystals are small enough that they're probably not going to go anywhere. And usually dioptase is it doesn't typically form with huge crystals. It's hard to find that, and if you can, it's probably going to be exceptionally expensive. But this specific mineral has got copper in it, giving it that green hue. The other thing that's kind of cool about it is it forms in hydrothermal areas. So you get hydrothermal alteration, which is just basically hot water, typically from a magmatic system, because in addition to I know, bubble wrap the garnet. In addition to having magma systems, you actually do get heated water in the ground that can flow because of magmatic systems. And these waters can alter and grow different minerals in different locations, depending on the ions and the cations and, et cetera, that are available. So the elements that are available, right? So you need specific, magmatic just means, it has to do with magma, basically. It can be, yeah, thermal vents, exactly. So so if you've got a magma chamber, right? A big magma chamber, that heat dissipates. So any groundwater you're going to have around that can also heat up. That heat doesn't just stop at the magma chamber. That's not how that works. So in certain cases, you can have water that actually alters various minerals. Excuse me, Mr. Mineral, I'm going to need to see your ID. But dioptase is absolutely one of my favorites. I just wanted to show it off because of how nice the color actually finally looks. Another one that was really glorious. Oh, yes. My Celestite. That light gray, cloudy blue I told you, you can actually see all of the various crystal planes. When you see the light reflecting off of a plane, like, well, any of them, we can use that to determine, well, is that cleavage? Is that the mineral shape? Or determine what kind of luster it is. How does the light actually reflect or transmit or absorb through the mineral? These are important properties that we can use to identify these. In this case, this is Celestite. I've also heard it called Celestine. It is a strontium sulfate geode. And these are actually pretty cheap to find. Celestite isn't super expensive. I've seen it sold all over the place. It's not too expensive at all. Does that answer your question, vulgarities? Can you cover Birefringence yet? I mean, I can kind of with calcite, but I mean, that's kind of the extent to which I can cover it without a petrographic microscope, Fragile. I don't know how else to talk about it. Tend to get a little emotional. All right, I want to show you some other things first. So, if you guys remember the other day, I'm not going to tell you what this is. All right, this is a mineral, okay? And we smashed it because it actually smashes into the same exact shape. These are little pieces from the one that we smashed. And those are called cleavage planes. And those happen because on the atomic scale, there's a specific weakness in a very specific direction, sometimes up to 4 directions. You can have 4 different cleavage planes. And at the atomic scale, there is a weakness such that when you smash a mineral or try to break it, it will naturally cleave along those planes. And I'm not going to get into the crystal classes today, but I do have a lot for the video that I plan on recording when it comes down to the 6 crystal systems and the rotational symmetry and how they form. But that is going to be a little bit beyond the scope of the lecture today. So I just wanted you to see that that's what cleavage is, all right? This mineral here has an interesting light property called Labradorescence. And obviously, okay, I'll just give it away. It's Labradorite, all right? But do you see that almost fish scale iridescence? It's called Labradorescence. And on this plane, if I angle it this way, it just kind of looks like dark or uneven, maybe kind of gray. I turn it this way, you can almost see some green and blue. You definitely see it over on this angle. You even see almost some yellow. You just rotate it. And that's a very distinct property to this mineral, Labradorite. Labradorite is one of many feldspars. This is the side that they cut, and you can see some of those colors almost better. And you can also see striations, so parallel lines of growth. Do you see that? Those little lines that are parallel to one another? Those are called striations. Hold on. Light! You could see them in that light, kind of. Geology does love cleavage, yes. But that light effect here is called Labradorescence. And I will eventually teach you the science behind that. Because I don't know off the top of my head right now. There are also properties that, let's put down something with letters on it. How about this? Rocket Sage logo. So there's something that somebody asked me about birefringence. This is actually a type of birefringence. You can see that the light penetrating through here makes a double. There's 2 different circles now through here. Do you see that? How it doubles the image beneath. Yes, Fragile. You were asking about birefringence. You knew it was calcite. Well, no, you gave it away. But okay, I kind of gave it away because I showed you that initially. So I'm kind of giving you I'm just showing you some various properties, and then I'm going to go through the list and the actual lecture that I have in a moment. I want to show you all the different tools that we use first. So this is called double refraction. The light penetrates here, and you can see that it's just one circle. You put it on there, and you can actually see 2. I'm wondering if a thinner piece would better demonstrate that. Maybe not. Maybe not. That one's not as good. This one, however, it just goes straight through. You don't see that double reflection. That being said, this has kind of got a rough surface, but that's just because it's been used in the lab a lot. And this one looks also very similar, right? You can't see through that one as easily. So we're going to look at these here. I'll just put that one. These little guys. I'm going to put the Labradorite back. And I'm going to try to find some other minerals that actually look like this. I'm going to find minerals that are all very, very similar in color. That's what I'm going to do. Actually, this is a better sample than that one. Where did I have this? What's that? Let me see. Let's see, there's, oh, that one's too unique to identify. There's this. There's this guy. It's pretty similar in color. And I'm taking some of these out of my Mohs hardness kit, by the way. You cheated too. I remember. It is. That is a very good point, Fragile. That's a very good point. Yes. So there is. Let's see. There are 5 different minerals here so far. So I have multiples of some of them, right? Are you guys ready for this? Do I have some polarizing film somewhere? No. In that way, yeah. Could do the cross polarization and the plain polarized light with those polarizing filters. Fragile, that's not a bad idea, to be honest. I've never tried it, though, with hand samples. Calcite isn't always recognizable because it can fill cavities in weird ways. Like, I don't know, this. That's also calcite. Has no shape to it because it filled a space in diagenetic settings, which allowed it to, well, be a completely different space. So I can do away with this guy, but we're going to look at all these minerals and identify them via the properties. First of all, these are called streak plates. We use these to determine what color a mineral is when, well, dragged across one of these plates, or if it's too hard to drag across one of these plates, you can potentially pulverize the mineral, and it can be a very different color than the mineral itself. Not in all cases, but in many cases, like hematite. Let me show you this. Hematite, it's an iron oxide, so it's iron and oxygen. That's it. This is a variety called specular hematite. And finally, you can actually see, you can see that glitter, which is very, very, very typical of specular hematite. So if I take it on the streak plate, you have a reddish brown streak. Yeah, exactly, Fragile. So you have a reddish brown streak there, right? So that's an example of streak. And those are very, very distinguished. I mean, look how different that is. The mineral itself, yeah, it's kind of a silverish submetallic gray, but the streak itself is brown, brownish red. You like that sound? So that's a very important property to note. You've got your streak plates. Additionally, that one's not. I don't have anything magnetic. I don't have any magnetite, unfortunately, so I'm not going to be able to use that example. But I always keep a little magnet around because magnetite and sometimes hematite can be slightly magnetic. There are other minerals as well that can be magnetic too, not just hematite and magnetite. So it's not a bad thing to keep around, just a little magnet for these things. Another thing you're going to want to use are glass plates. This has a hardness of about 5.5 on the Mohs hardness scale, which I'm going to show you momentarily. Additionally, your fingernail has a hardness of about 2.5. A copper penny, I think before the year 1980, has a hardness of about 3.5. And you can use a steel file or a steel drill bit, I believe, which you have to make sure that it's, I think, the right alloy. I'm not sure. But it has a hardness of 6.5. So those are other things we can use because on the Mohs hardness scale, you have minerals going from 1 to 10. And you do want to know which mineral has which hardness because it can be a very distinguishing property to identify said mineral. Color, as you can see, look at all of these minerals. There are like 6 different minerals here. All right? Like 6 different minerals there, but they all look very similar. Some of them are shapeless. Well, no, they're not all quartz. They're not all quartz. There's only 2 pieces of quartz. There's only 2 pieces of quartz in that pile. Because of its shape, I thought I would use it as a, hopefully to throw some people off and show just how important it is to use very specific diagnostic properties. The orange lump? Mm-mm. Nope, it's not halite. That's why Just using your eyeballs and looking at it, not the best way. Color is not the best way. And I'm going to show you why, all right?